This video is part of the project Widening Indigenous Participation in Higher Education through Strategic Partnerships, supported by the Department of Education HEPPP Partnerships Project Funds. This is a video for the measurement section of the Mathematics General 2 course. The video will demonstrate calculating trigonometric ratios, calculating in right-angled triangles, compass bearings, and trigonometry involving direction. Example 1. Find the value of sine 37 degrees, correct to 3 decimal places. The value of sine 37 degrees is found using the calculator. It is important to make sure your calculator is in degrees mode before entering any values. So when we do sine and 37, we get the answer there. We round that then to 3 decimal places. Example 2. Find the size of angle theta, correct to the nearest degree, if tan theta is equal to 0.417. Using the calculator to find the value, it is important that you press either the shift, inverse, or second function button, whichever your calculator has, before you press the tan button in order to get the angle out. When you do, it gives the angle as a decimal. You need to use the degrees, minutes, and seconds button to change that to degrees, minutes, and seconds. And then rounding to the nearest degree, you get 23 degrees. This could be rounded from the decimal or from the angle notation. Example 3. Using the sine ratio, find the size of angle theta, correct to the nearest degree. Noting firstly that is a right angle triangle, then we're able to use sine, cos, or tan. Because we have the hypotenuse, the side opposite the right angle, and the side opposite the angle, which is the opposite, we're going to use the sine ratio. Putting the numbers in, we have sine theta is equal to 8/13. Again, you need to use the shift, inverse, or second function button before sine to get the angle out. It's important to put the 8/13 in brackets when you're doing the calculation to make sure that the calculation is correct. The angle comes out in degrees and minutes, and it's rounded to 38 degrees. Example 4. Using the tangent ratio, find the length of the side x, correct to 1 decimal place. Again, we have a right angle triangle. Looking at the sides, we don't have the value for the hypotenuse. We have the value for the adjacent side and for the opposite side. So we're going to use the tan ratio, which is adjacent over hypotenuse. Putting in the values, we have tan 47 equals x over 10. Multiply both sides by 10 to get x equals 10 tan 47, and then you use your calculator to get the value. Rounding it off to 1 decimal place gives us 10.7 centimetres. Example 5. Find the true bearing of A from O. Bearings are measured from north in a clockwise direction. So north, south, east and west are all separated by 90 degrees. So between north and east is 90 degrees. And then it goes another 32 degrees. So we do 90 plus 32 is 122 degrees true. Example 6. A town A is 43 kilometres in a southwest direction from town B. Find the distance that town A is south of town B. The first step we need to do is to draw a diagram showing all the information. The direction southwest is in between south and west. That means that it would be at 45 degrees. So our triangle is drawn here with 45 degrees as the angle and 43 kilometres as the distance between A and B. To find the distance south, we want to find the adjacent side, labelled with X. Since we have adjacent and hypotenuse, we use the cosine ratio. Substituting the numbers gives cos 45 degrees equals x over 43. Multiplying both sides by 43 and using our calculator gives us our answer of 30 kilometres to the nearest whole number. Now please pause the video as each question comes onto the screen, then complete the answer and restart the video to see the solution. Then repeat that process for each question. There are 5 questions based on the examples provided, and you are to do the solutions. Question 1. Find the value of tan 84.3 degrees correct to 2 decimal places. Pause the video now. Using the calculator and rounding it off, the answer is 10.02 to 2 decimal places. Question 2. Find the size of angle theta correct to the nearest minute if cos theta is equal to 0.1977. Pause the video now. Using your calculator, remember to press shift, inverse or second function first, depending on which calculator you're using, before you press cos. Then press the degrees, minutes and seconds button and round it off to the nearest minute, which means if it's 30 or more, it gets rounded up. If it's less than 30, it remains the same. Question 3. Use the cosine ratio to find the size of angle theta correct to the nearest degree. Pause the video now. We have the adjacent and the hypotenuse. So cos theta is equal to 14.3 divided by 21.8. Again, remember to press shift, inverse or second function depending on your calculator before pressing cos so that you get the angle out. It's best to put that division in brackets when you're using your calculator. Use the degrees, minutes and seconds button to turn it to degrees, minutes and seconds. But here you could have rounded it straight from the decimal because you're doing it to the nearest degree. Question 4. Using the cosine ratio, find the length of the side x correct to 2 decimal places. Pause the video now. We have the hypotenuse and the adjacent side. Substituting in the values into the equation gives us cos 38 degrees equals x over 30. Multiply both sides by 30 and use your calculator to get the value. Round it then to 2 decimal places to get 23.64. Question 5. Find the true bearing of A from O. Pause the video now. Bearings are measured from north in a clockwise direction. All the way around is 360 degrees, and we've got 29 that we're not using. So do 360 minus 29, and our bearing is 331 degrees true. Question 6. A ship sails 57 kilometres from a port A on a bearing of 321 degrees. How far is the ship west of port A? Pause the video now. First, we need to draw a diagram. Here's our diagram with our bearing of 321. To get the angle in there, we need to do 321 minus 270 because it goes past west, which gives us 51 degrees. Now we use the cos ratio. Cos 51 is x over 57. Multiply both sides by 57 and then use your calculator, rounding the value to 36 kilometres. There are another 5 questions for you to answer. Again, pause the video after each question and then the next slide will show the solution. Question 1. Find the value of cos 64 degrees 28 minutes correct to 2 decimal places. Pause the video now. Using your calculator, the value is 0.343 to 2 decimal places. Remember that you need to use the shift, inverse or second function button on your calculator to get the angle. Question 2. Find the size of angle theta correct to the nearest degree if sine theta is equal to 2 over 5. Pause the video now. Make sure your calculator is on degrees before you do your calculation. And remember, you've got to press shift, inverse or second function to get an angle out. So we do shift and sine of 2/5, rounding it to 24 degrees. Question 3. Find the length of side X correct to 1 decimal place. Pause the video now. Because we have the opposite and the hypotenuse, we use sine. Sine 38 is equal to x over 6.9. Multiply both sides by 6.9 and use your calculator to get the value of x, rounding to 1 decimal place. Question 4. Find the true bearing of A from O. Pause the video now. Our bearing doesn't quite make it to 270 and it's 53 degrees away. So we do 270 minus 53 to get a true bearing of 217 degrees true. Question 5. A ship is 92 kilometres east and 64 kilometres south of a port O. Find the bearing of the ship from port O. Pause the video now. First, we need to draw the diagram. So we go 92 east and then down 64 and we make a triangle. We need the value of theta, the angle in that triangle. We use tan, opposite over adjacent, to calculate the angle in the triangle of 35 degrees. Now, because that's 35 degrees below east, we do 90 plus 35 to get the bearing of 125 degrees. This video is part of the project Widening Indigenous Participation in Higher Education through Strategic Partnerships, supported by the Department of Education, HEPPP Partnership Project Funds. This concludes the video. Thank you.